Thank you very much for the introduction. So, highway to heaven building microservices in the cloud at AutoScout. And the picture below is the reason why we don't like tight coupling. So my name is Christian. I'm an architect at AutoScout. I'm with AutoScout for 5.5 years. And as already mentioned, AutoScout is in the listings business. So if you know AutoTrader, we are more or less the European version with about 2.4 million listings all over Europe. There is a gray spot on our map, which we currently are in. So almost everywhere in Europe we are available. Core market is Germany. And of course, we had a data center and an enterprise IT set up quite some time ago. This is what we call our cache stack. We used to have ASP.NET with Windows as an operating system. The database was Oracle, and the whole data center or data centers were virtualized with VMware. And the whole thing is still running and is supporting the business. This is why we call it the cache stack, because it's still earning the money, because we are in a transition phase right now. We are migrating stuff. So we have 2,000 virtualized servers in 2 data centers, and the whole hardware setup is very strongly optimized for mean time between failure, meaning redundant power supplies, VMware magic, so that actually the software developer has the feeling the hardware never fails. He just can write his monolithic software and assume it runs. He also just can assume that if he writes slow software, people will buy new hardware to make his software run faster. We of course had the typical split between software development and operations with the silos. And some of us, especially in the development crowd, were not so happy with the VMware-based setup, because despite being virtualized, we heard this all over the day, it took quite some time to set up one of those VMwares, and it was never fully automated. So we believed we need to go to the cloud, but you can also call your VMware setup private cloud, and then you get into the struggle to argue why you should improve. We also had and still have proven agile and lean principles. So this is something we can build on top. This is supporting our platform, but nevertheless, we wanted to change. And one of the things we wanted to change was going to the public cloud, because we wanted to stay with the rest of the world. Rest of the world meaning for us being where Guild, Netflix, etc. was. We didn't want to end up on the red line. But there was friction within the company, and in the end of 2013, Scout24 was sold to private investors, and the new CEO came on board. And at that point in time, we told him, we are great. This is working. Everything is fine. And then he started asking questions. So, are you ready for the 21st century? Is this the company of the future? And one of the important questions he asked was, do you attract talent? So, being a .NET shop, we get a lot of good .NET developers, especially in Munich, from banks and insurances. But we need to tell them how the internet actually works. So they don't bring all the capabilities that companies like Netflix and etc. Are building on top of the JVM, for example. And then we came up with that picture where we were reasoning about that the flywheel of technology and excitement and community and talent in the .NET ecosystem actually works, but that in the JVM ecosystem, it's going way faster. So this was one of the reasons why we wanted to get rid of .NET, despite that we liked it, but we just couldn't attract the talent we needed to go forward. Another reason we wanted to get rid of .NET was actually the operating system below it, Windows. This is whoever is running Windows in the data center. This is not easy to automate, and we wanted to improve on our automation, so going to a Linux-based system was something we would like. So after initially we thought we are great, then we only believed we are only good. So what to do about it? As it was already introduced, we believe that we need to change everything at the same time. We overcome the inertia within the company. We try to solve everything at the same time. And the code name for this change was Project Tatsu, and the roller coaster you have seen in the introduction, this roller coaster is called Tatsu, and this is how this project also feels like. So we are changing from .NET Windows to JVM Linux, more specifically on the JVM to Scala. We are changing from a monolith to microservices, and we're going from the data center to AWS. And we're changing the dev and ops silos into a collaboration culture. And all the while, we don't want to just do a technical transformation of the same old application. We also want to involve products so that after the migration, also AutoScout is a shiny new AutoScout. This is how our migration strategy from a technical perspective looks like. As you can see, we have one big monolith still in the cache stack, but we also have those what we call swim lanes. Those swim lanes were introduced as we were working on continuous delivery, because the monolith took quite some time to be released. So some teams just started out building new swim lanes, cutting stuff out of the monolith to actually increase their cycle time for continuous delivery. But those weren't proper services because they shared a lot of business components, and most importantly, they shared the database. So when reasoning about microservices, we also believe that the vertical slice is for us the first and the right step. This is not as the typical Netflix microservices architecture where you have lots of small services. Our services are rather small. Nevertheless, they share the trait that they are organized around the business capability and are actually a vertical slice that goes from the UI all the way down to the back end. If you want to read up on that architecture style, there is a name, Self-Contained Systems, which is described by Stefan Tilkoff in depth. And our migration strategy is then to carve out those business capabilities out of the existing monoliths or swim lanes and rebuild those services on AWS as a little bit bigger microservices. We started in the end of 2014 with one team. Everything was new to us, so there were 8 engineers. Most of us weren't familiar with Linux, JVM, AWS. We bootstrapped everything, and those were also the guys who were very tightly aligned to what they want to do. So they talked about this project all the time, and they made upfront ideas and really knew where they want to go. But then as we ramped up teams, so over the course of the next year, we ramped up to about 8 teams. We're now at 10, 12 teams. And at the point in time where we were at 4 teams, we started to recognize that actually the initial core beliefs, how we should build stuff, our principles, how this all should work, were actually not present anymore. People were doing things which violated what we believed is true. So we were not going in the same direction. This is the reason why we then came up with our set of principles. Those principles should support our strategic goal, and as you heard over the day, over and over again, the most important thing behind microservices and the organizational and cultural changes that we want to be fast, and we want to have fast feedback, and we want to increase or reduce the time to market. Of course, we want to also support data-driven decisions. We want to get better there. And then going to the cloud, also the notion of cost efficiency comes into play, because on AWS you actually have a very good insight in what your services are costing. So these are our strategic goals, and we have come up with a set of architectural principles. Some of them are generic, and some of them are very closely related to what our culture looks like. So this is has been a very good exercise for us for discussions and also for coming up with those principles and also getting feedback on those principles. This is a very valuable tool to actually align behind the things we are going to do. So if you want to do this, just please don't copy those principles as they are, because these are our principles. Just use this as an idea, as a template, what you can do with those kinds of principles. I won't go deep into any of those principles, but during the remaining parts of the talk, we will touch some of them. The most important thing, and this, I'm repeating a lot of things we heard all over the day. This is the advantage of having the last talk in the evening. That is more or less a recap of everything. We strongly believe in autonomous teams that are organized around the business capabilities. And as you heard before, our services are also aligned around business capabilities. So Conway's law comes into play, and those teams, and we are doing that to actually scale the organization. Those autonomous teams can actually work and make fast local decisions without using up a lot of communication bandwidth all over the company. We have learned that at about 20 engineers, our old monoliths started to become painful when doing collective code ownership, and this model helps us to be fast and decoupled. Of course, products, not projects, so those teams should actually own their services. We also, when we started with our first team, we put in software developers and operation guys into the same team to actually have a collaboration culture within the team where DevOps is no longer a role or a team or a tool for us. It's the collaboration between operations and software guys. And we managed to get rid of the silos mentioned that were still existing in the cache stack. And this has great advantages. The team now feels way more responsible. And to actually make this more explicit, we now call ourselves engineers. We are all engineers. We try to get rid of you're a software developer and you're an operations guy. Now everybody is an engineer and is working on the same team. But there is something you need to look out for anyway. People new to the project still split up into two teams within a team. So the silos you had on an organizational level might reappear at a team level, where on one side of the room, the engineers are coding away in the application, and on the other side of the room, the operations guys are building the infrastructure despite being in one team. So we tried to, with pairing and shifting tasks, to actually compensate for that, but this is a danger we are still facing. Of course, the whole team in itself should then be able to work cross-functional, and there will be experts in there because not all T-shapes are the same, but in essence, over the whole team, all functions should work. This leads us to the you build it, you run it meme, which is a very strong change for us. The teams are now responsible for their services. We heard this all over the day, and this actually frees up a lot of energy within the team. Initially, you will believe now they have the additional burden of actually maintaining their service, but they like it. They take on the ownership. They actually care for their services. Initially, when they're on call for the first time, they're afraid that they have to stand up in the evening fixing services, but they're actually constantly improving on their services so that they don't have to stand up. And the feedback, and this is what we had seen on the strategic goal, and fast feedback then also works within the team. If you build a good service, you don't have to wake up in the evening for us, and if you build a bad service, you have to wake up. So the feedback actually goes back to the one responsible and not to a different department that is on call for the service. And this leads then more or less automatically to more resilient services because the teams are responsible for it. Then we come to continuous delivery. At Autoscout, or when I joined Autoscout, we released our monoliths about every 4 weeks. And improved on that so that before we started Project Tatsu, the monolith was released every other day. And the swim lanes I mentioned previously, we released many times a day. But at that time, the continuous delivery was still a code-only delivery. So the server were running as VMwares in the data center, and they were configured up front, and we just shipped new software on those services. We did that with all the tools we had available and all the practices around continuous delivery. But in the end, configuration changes, configuration drift, and everything that you might know still happened to us. So we actually also wanted to improve on that. And by picking AWS as a provider in opposition to something like VMware, we now have the feeling, at least for Autoscout scale, that we have unlimited infrastructure, and this infrastructure is available to us as an API. There are many reasons why you could pick AWS. You avoid the undifferentiated heavy lifting, you support business agility, and you have many of those higher level managed services from AWS. But currently, the thing I like most about AWS is that every piece of infrastructure, every resource I can generate there has an API, and I can also query what the state of my infrastructure is. Which leads us to infrastructure as code, which is now something that's possible. We have one repository where the application code is in, and in the same repository, the infrastructure definition is sitting. And the same continuous delivery pipeline that's delivering the code changes is also doing the infrastructure changes. So for one of our services, there is no difference in an infrastructure change or in a pure code deployment change. It's the same continuous delivery pipeline, which gives us very high traceability and repeatability. But it even gives us one thing more beyond infrastructure as code, is that now every change in our production system goes through this delivery pipeline, which in reverse allows us to actually have an alert in place. There is a service called CloudTrail on AWS, where every API call is logged. And if there is an API call to change an infrastructure in production which is not triggered by our delivery pipeline, we create an alert. An unexpected production change happened. So we are now, and the whole team gets this. So you only do this once. And now we are actually sure that everything that's in production is delivered via a delivery pipeline, and there are no manual changes in production whatsoever. And this is the advantage of having an API that enables things like that. Of course, we also do immutable servers. So the cattle not pets meme, servers are recreated for every deployment, no configuration drift, no SSHing into the machine and doing a manual configuration. It won't survive for a long time. We are still not in the Docker realm. So currently our cycle time is around 20-25 minutes for those services, mainly due to the EC2 startup time. But currently it's good enough for us. But having this immutable server in place gives us, similar to the infrastructure as code meme, also the capability to now monitor for the age of those instances. For immutability, we are not patching the services when they are running, because they would then change. We are only patching them via a new AMI, base AMI. And for those new patches for the Linux operating system to go into production, a new release is needed. But on the other hand, we are now monitoring that no instance on AWS is older than 2 weeks. So in prior times, we bragged about the uptime of a service. And now if a service is too old, we actually get an alert. There is an instance too old. There might be missing security patches. Please trigger the delivery pipeline to update the service. And something also we heard all over the day is that you need to do a lot of monitoring when doing microservices. And of course, you still need to do testing because defects you can find before you go into production, this is of course very valuable. But when many services are independently deployed into production, you also need to monitor that the interaction between those services are still working. So we're doing user journey tests where core business functionalities are exercised externally every 5 minutes. And if those are not working, we get an alert. And what's also very interesting on this, this about a month old, I took a picture of one of our teams, what kind of things teams come up with when you give them the ownership of their services. Nobody told them to actually do this kind of exhaustive monitoring and build a dashboard like this, but they're putting things on there which we dreamed of before that. For example, they have the AWS cost from the previous day for their service on there. So they know if they're doing something stupid and the instance count is increased due to more load, the cost will increase there, and they're just aware what their service is costing. Over there, they have the Ops Genie alert. So if they have unacknowledged or open alerts, they can see it on their dashboard. Of course, they're seeing the latency of their services. They're actually measuring the page speed of the web page they're delivering, measured via Google, and everything else is on there, which nobody told them, but they now feel the power to do it, and they're taking the responsibility on and are taking care for their services. Also something in the meme of continuous delivery, we started that before microservices. Even in our monoliths, we did a lot of feature toggling, no feature branches. We tried that once. This was a deep rabbit hole we got into. Trunk-based development, feature toggles, and alongside with feature toggles, also dynamic feature toggles, which allow you to do canary releases for features, or to actually give product or QA or your automation the capability to introspect the behavior of your application being in production. So we are actually shipping our code all the time into production. We're just not enabling the feature. Which comes to the next point. In our cache stack environment, in the beginning we had 2 staging environments, and a development environment and a production environment. And we constantly struggled to keep those environments production-like. Never managed to do so. Despite that the environment should be production-like, we found defects in production which didn't occur in the staging environment. And when going to a microservice world, this actually does not work anymore. When you look at, for example, the yellow service in version 5 is integrated with version 2 of the blue service in the staging environment. And after the yellow service goes into production, what happens? It's now integrating with version 1 of the blue service. So it gives you a false sense of security, your staging environment, that you're actually verifying that you have a running system, but you mix and matching the versions because all of those services are deployed independently. And the problem is increased the more independent deployable services you have. So we also said we don't do that. A lot of cost involved with the staging environment, not so much gained, and we rather invest in tools and processes to actually verify everything we need to do in the production environment, doing stuff like consumer-driven contracts, shadow traffic, canary releases, and feature toggles allow us to actually be bold and only integrate in production. This is quite a shift for the people, because if there's something dangerous they want to do, they actually try to test it before they go into production or to integrate. But we are learning that this actually is not good. No staging environment for us, less complexity for maintaining it, and you are faster. That's it. Thank you.
Christian, that was a great talk. I really like the idea of getting rid of staging.